In this episode, we zoom in on a place where privacy risk often grows quietly and then suddenly becomes obvious: data lakes and data warehouses. For a beginner, these can sound like neutral storage concepts, like a big library where an organization keeps information so it can learn from it. The privacy challenge is that aggregation changes the nature of data. Separate datasets can feel limited and contextual, but when you combine them, you can create a rich, detailed picture of a person's life and behavior. Even if each dataset was collected for a reasonable purpose, the combined dataset can support uses that were never intended, and it can enable inferences that surprise people. Aggregation risk is the risk that putting data together makes it more sensitive, more linkable, and more harmful if misused or breached. The goal of privacy engineering here is not to ban analytics, but to reduce the risk that a lake or warehouse becomes a single, irresistible source of overreach. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To understand aggregation risk, it helps to start with the idea that context is a privacy boundary. Data collected in one context, like a customer support ticket, carries an expectation about how it will be used. Data collected in another context, like app telemetry, carries a different expectation. When you pour both into a single warehouse and join them by a stable identifier, you erase those boundaries. Suddenly, the same person can be seen through every lens at once: what they bought, what they clicked, what they complained about, where they connected from, and how often they returned. This is powerful for analysis, but it also creates a surveillance-like capability that many users would not anticipate. Context collapse is one of the most common reasons aggregated systems feel invasive even when each source alone might be defensible. Reducing aggregation risk means preserving context boundaries even inside analytics infrastructure. A data lake is often described as a place where you store raw data in its original form, while a data warehouse is often described as a place where data is cleaned and structured for analysis. From a privacy point of view, both can create the same core problem: a central place where many datasets meet. Lakes can be especially risky because they tend to keep raw data, and raw data often contains more personal detail than anyone needs for most analysis. Warehouses can be risky because they are designed for joining tables, and joining is the mechanism that turns separate facts into an individual profile. Beginners should remember that privacy risk is not only about storage volume. It is about linkability and reach. A single central store increases reach because many teams can access it, and linkability increases because it is designed to connect everything together. If you want to reduce risk, you have to manage both reach and linkability. One of the first practical controls is deciding what should never enter the lake or warehouse. Not all data belongs in a shared analytics environment, especially data that is highly sensitive or easily abused. For example, the full content of private messages, detailed support transcripts, or highly precise location trails are often too risky to centralize. Even if you could justify storing them somewhere for a narrow operational purpose, that does not mean they should be available for broad analysis. A good minimization mindset asks whether a dataset's value is mostly operational and short-lived, and if so, it may not belong in the long-lived analytic core. Another helpful question is whether the dataset could create serious harm if combined with other common datasets. If the answer is yes, you should consider keeping it segregated or transforming it before it enters the aggregated environment. Transformation before aggregation is one of the strongest privacy patterns. Instead of loading raw data, you load reduced data, aggregated metrics, categories, truncated values, or derived signals that meet analysis needs without carrying full personal detail. For instance, instead of storing exact timestamps of actions, you might store counts per day, or store time ranges that are less identifying. Instead of storing full IP addresses, you might store a coarse location region. Instead of storing free text fields, you might store coded categories selected from a controlled list. The reason this works is that it reduces the chance of reconstructing detailed personal narratives from the warehouse. It also reduces the chance that analysts inadvertently discover sensitive facts about individuals because the raw ingredients are simply not there. Reducing risk is often easiest upstream, before the data is centralized. Identity resolution is another major driver of aggregation risk, because it is the process of deciding that multiple records belong to the same person. In a warehouse, identity resolution often happens through stable identifiers like account IDs, device IDs, cookies, or email hashes. When identity resolution is strong and broad, aggregation becomes powerful, and power is what creates privacy risk. Reducing aggregation risk often means limiting identity resolution to what is necessary for a specific purpose and avoiding creating a universal identifier that ties everything together. For example, you might allow joins within a single product line but prevent joins across unrelated services. You might keep different identifiers for different contexts so that cross-context tracking is not automatic. This is not about pretending people are different across systems. It is about preventing the analytics environment from becoming an all-seeing profile engine by default. Access control in lakes and warehouses is often treated as a security issue, but it is also a privacy issue because broad access invites broad use. If hundreds of employees can query raw event-level data, someone will eventually use it for an unapproved purpose, even if they believe they are solving a problem. A privacy-aware approach limits access to raw data, provides safer derived datasets for most users, and encourages analysis on aggregated outputs rather than on individual-level records. It also uses auditing and monitoring so access patterns can be reviewed. For beginners, the key takeaway is that privacy is not only about what data exists, but who can see it and how easily they can combine it with other data. A warehouse with tight access and safe defaults behaves very differently from one that is open to anyone with curiosity. Another important control is separating data by sensitivity tiers and by purpose, even within the same overall analytics ecosystem. You can think of this as creating zones, where each zone contains data that is appropriate for a certain kind of analysis. A low-risk zone might contain aggregated product metrics that do not identify individuals. A higher-risk zone might contain pseudonymized event data that only a small group can access for specific analyses. The point is not to make analysis impossible. It is to make high-risk analysis rare, deliberate, and reviewable. When everything is stored in one flat space, it becomes easy to do high-risk joins accidentally. When zones exist, the system reminds analysts that they are crossing a boundary and that crossing requires justification. This structural friction is one of the best defenses against gradual drift into overreach. Retention in lakes and warehouses is also a frequent source of aggregation harm because centralized systems encourage long-term storage. Teams want history for trends, comparisons, and model training, and it can feel harmless to keep raw data indefinitely. The privacy problem is that long retention allows deep longitudinal profiling, and it increases breach impact dramatically. A better approach is to define retention windows for raw records and then roll them up into less detailed forms over time. You might keep detailed events for a short period, then keep weekly aggregates longer, and then keep only high-level trend indicators after that. This preserves analytic value while reducing the ability to reconstruct individual behavior over years. It also forces teams to justify when they truly need raw history, instead of defaulting to indefinite storage. Aggregation risk also shows up in the way analytics teams work, especially when exploratory analysis turns into production scoring. Analysts may discover correlations that lead to models, and those models can influence decisions about people. If the warehouse contains broad cross-domain data, models can incorporate sensitive signals, even unintentionally. That can create unfair outcomes or manipulative targeting, particularly when the system starts treating people differently based on inferred traits. Reducing aggregation risk includes limiting what features can be used for certain decisions and maintaining clear boundaries between measurement for product health and profiling for influence. It also includes checking whether analysis goals can be achieved with aggregated data rather than individual-level data. Beginners should understand that analytics is not just reporting. It can become decision-making, and decision-making raises the stakes. A misconception worth correcting is that removing obvious identifiers makes a warehouse safe. Even without names and emails, event-level data with timestamps, locations, and unique behavior patterns can often be linked back to individuals. Another misconception is that aggregation is only risky when data is shared externally, but internal aggregation can still create harm through misuse, inappropriate decisions, or breaches. A third misconception is that if data was collected with notice, then any internal combination is fair. Notice rarely communicates the full power of cross-dataset joining, and people usually do not imagine that their data will be merged into a single profile spanning many contexts. Privacy engineering responds to these misconceptions by focusing on real capabilities, not just on labels. If your warehouse can reconstruct detailed personal stories, it deserves stronger controls, regardless of what you call the fields. Defensibility is the practical standard that ties everything together. If someone asks why you built a warehouse that can connect so many datasets, you want to show that you anticipated the risks and designed guardrails. You can point to decisions about what data enters, how it is transformed, which identifiers exist, who has access, how long data persists, and how high-risk joins are controlled. You can also show that you have processes to review new datasets before they are onboard, and to review new analyses that cross sensitive boundaries. Defensibility is not about proving perfection. It is about showing discipline and intentionality. When aggregation is treated as a high-risk capability that requires boundaries, the system becomes more trustworthy and less likely to drift into profile building by default. When you reduce aggregation risks in data lakes and warehouses, you preserve the benefits of learning from data without turning the organization into an accidental surveillance machine. You keep context boundaries alive by limiting what enters the shared environment and by transforming data before it becomes centrally joinable. You restrict identity resolution so profiles do not become universal by default, and you use access controls and sensitivity zones so most work happens on safer datasets. You set retention rules that reduce long-term profiling and limit breach impact, and you pay attention to how analytics can evolve into decisions that affect people. Done well, this approach keeps the warehouse a tool for understanding systems and improving experiences, rather than a tool for collecting and exploiting personal lives. That is what responsible privacy engineering looks like when the data is big and the temptation to connect everything is even bigger.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.